One really useful technique in trigonometry is to use identities in order to take a complex looking trig expression and change it to be a simpler expression. Here in the last part of this section, we are told to take each expression and write it in terms of sine and cosine. We're going to use identities in order to do that. And we want to simplify so that no quotients appear in the final answer. And when it says that, it simply means we want to write our answer with no fractions. So we want no fractions in our final answer. And we want all of our functions to have an input of theta only. So not negative theta as input, but just positive theta. So let's look at our first example. We have secant theta times cotangent theta times sine theta. So we are asked to write each expression first in terms of sine and cosine. So let's look at secant. Secant would be 1 over cosine theta times cotangent. Cotangent would be cosine theta divided by sine theta. So we're using those identities to take what we have and change them into identities that use only sine and cosine. And the last one is sine. That's already written in terms of sine, so we will leave that as it is. Think about that as sine over 1. And I want to get rid of all of my fractions. I don't want to have fractions in my final answer. We see that we could start to cancel across the fractions. We have cosine theta divided by cosine theta. We can cancel those. Sine theta and sine theta can cancel. And what we're left with when we multiply across is just 1 over 1. So our final answer simplifies to be 1. And we can all agree that that is a lot nicer than the expression with those 3 trig functions that we started out with. Okay, for the next example we have a fraction, and we have cosecant theta divided by cotangent of negative theta. So first, let's use that odd function identity. And let's change cotangent of negative theta to minus cotangent of positive theta. So we're using that identity to replace negative theta with positive theta. So the negative that was on the inside can come on the outside of an odd function. Now let's take what we have and write everything in terms of sine or cosine. So cosecant is the same thing as 1 over sine theta. Cotangent, so let's say negative, that would be negative cosine theta divided by sine theta. We see that we have a complex fraction. We don't want any fractions in our final answer. So I would like to simplify this by flipping the bottom fraction and changing to multiplication. So we'll multiply the top by minus sine theta over cosine theta. Now we can cancel common factors. So sine theta and sine theta will cancel out. So we are left with minus 1 over cosine theta. Now, we don't want our final answer to have any fractions in it. So what is an equivalent expression to 1 over cosine theta that does not look like a fraction? Well, that would be secant. So I'm going to write this as minus secant theta. Alright, in this one we want to simplify. We want to write everything in terms of sine and cosine. We want to get rid of those negative thetas. We want to work with only positive thetas. Now, tangent, we talked about earlier, is an odd function. So we can actually replace tangent of negative theta. We could bring that negative to the outside. We could bring it to the front. So that would be replaced with the negative tangent of positive theta. And do the same thing on the bottom. We're left with a negative tangent theta. So now we've gotten rid of those negative thetas and replaced it with positive thetas. And now let's go through and replace tangent with sine and cosine. So we're going to use that identity, that quotient identity. We have 1 minus sine theta over cosine theta. So we're replacing tangent with that quotient identity. And the same thing on the bottom, we have minus sine theta over cosine theta. So we're asked to replace everything with and write it in terms of just sine and cosine. Now we are asked to write our answers without having any fractions. So once again we notice that we are simplifying a complex fraction and we have more than one fraction in the top. So we will need to multiply by the LCD of all of these little fractions within the larger complex fraction, and that would be cosine theta. So we're going to multiply everything, all of the terms, by cosine theta. You can think about that as cosine theta over 1, if that helps. And then we're going to simplify each of those multiplications. Well, the first term, cosine theta times 1, is just cosine theta. And here our cosines will cancel out, so we're left with minus sine theta all over, and on the bottom the cosine will cancel out, so we're left with minus sine theta. Now we were asked to give our answer without any fractions in it, so we went from a complex fraction to a simple fraction, but we still have a fraction, and we want to be able to reduce this to just be something that's not a fraction. So we have an important technique that we want to talk about. If I have two terms that are being added and subtracted on top of the same denominator, we can actually separate this into two separate fractions where they each have their own separate denominator. So we're going to give them back, instead of sharing minus sine theta, we're going to give them each their own minus sine theta. Okay, this is going to be helpful and a helpful technique, going from one fraction to two separate fractions, because now I can use identities to get rid of the fractions. Well, cosine theta divided by minus sine theta, cosine divided by sine would be cotangent, so that would be negative cotangent theta. And anything divided by itself is 1, and we have negative divided by negative, so we end up with a positive 1. So here we have our final answer without any fractions. Alright, once again, we would like to take this expression and change everything to be in terms of sine and cosine. So secant theta, we can write that as 1 over cosine theta. Cosecant theta is 1 over sine theta. So there's our first set of parentheses, everything in terms of sine and cosine. And in the second set of parentheses, we already have everything in terms of cosine and sine. Now we would like to multiply these two parentheses together. So let's think about this as cosine over 1 and sine over 1. And now we're going to FOIL. So first times the first. When I do those fractions, we multiply across the top of both of those fractions. So top times the top and bottom times the bottom. So when I do that, we get 1. So that reduces to 1. Outer times the outer, top times the top, and bottom times the bottom, we get minus sine theta divided by cosine theta. And of course, that is going to be the same thing as tangent theta. Inner times the inner, we get positive cosine theta divided by sine theta. And the identity for that would be cotangent theta. And then last times the last, we get negative sine theta divided by sine theta, so that gives us negative 1. So we have no fractions in our final answer, and we do see that we have some like terms. We have 1 and minus 1, and those can cancel each other out. So we're left with minus tangent theta plus cotangent theta. Alright, we want to take secant theta and cosine theta and write in terms of strictly sine and cosine. Secant theta would be 1 over cosine theta, And cosine theta is already, of course, written as cosine theta. And we don't want to have any fractions. We're going to talk about, we talked about earlier, giving them the same denominator. So if I were to subtract these two fractions, the LCD would be cosine theta. So I'm going to multiply top and the bottom by cosine theta. So that gives 1 over cosine theta minus cosine squared theta divided by cosine theta. Now they have the same denominator. We're going to keep the same denominator and combine the numerators on top. So we're going to combine those terms. All right. We're going to talk about a really helpful and useful technique here. And we see that we have 1 when we see 1 plus or minus a trig function squared. One of the things that we want to start to think about is our Pythagorean identities. And the Pythagorean identity that talks about cosine in 1 would be sine squared theta plus cosine squared theta is equal to 1. Now, we talked about taking our Pythagorean identities and rearranging them in a way that would be convenient. If I would like to replace the top of this fraction, 1 minus cosine squared theta, if I would like to take this and replace it with something that's simpler, but it's equivalent to that, what we can do is I can take my Pythagorean identity and I could rearrange it. Let's get one side to look like this, 1 minus cosine squared theta. So if I take my Pythagorean identity and I subtract cosine squared theta from both sides, then we end up with an equivalent form of that Pythagorean identity. Sine squared theta is equal to 1 minus cosine squared theta. So if this is equivalent to sine squared theta, then I'm going to replace 1 minus cosine squared theta in my fraction with sine squared theta over cosine theta. So we can do that replacement. It actually makes my fraction look a lot simpler than it did before. Now that I've done this replacement, I still don't want to have fractions in my final answer. So we're going to take care of that by thinking about sine squared theta as sine theta times sine theta. So let's separate it here. And let's write that as all over cosine theta. And if I write the top as sine theta times sine theta over cosine theta, if you think about it, this really is the same exact thing as sine theta over cosine theta times sine theta over 1. If I multiply these fractions back together, top times the top, I get sine theta times sine theta, and bottom times the bottom, we get cosine theta. So this is one of the things we want to start to practice, the ideas of taking one fraction and being able to separate it into two, and taking two fractions and being able to combine it into one. So these are techniques that we're going to start to use throughout the rest of this chapter. Now, how is this helpful to separate it from one fraction to two? Well, sine theta over cosine theta, that's the same thing as tangent theta. And now I have tangent theta, I have no fraction there, and then sine theta, well, we could just say multiply by sine theta. So our final answer here, without any fractions in it, would be tangent theta times sine theta. Alright, so our last example. We are asked to take each one of these functions and write them in terms of sine and cosine. So sine is already in terms of sine. Cosecant should be written as 1 over sine theta minus sine theta. And we're going to think about that as over 1. we have this sine theta. We're going to distribute the sine theta into the parentheses. So when we do that, we get sine theta divided by sine theta minus, and we have sine theta times a negative sine theta. So that's minus sine squared theta. Sine divided by sine, of course, is 1, and 1 minus sine squared theta. And let's practice with that idea that we just talked about, and that would be using a Pythagorean identity as a replacement to make what we see similar. So we have a Pythagorean identity that involves 1 and sine squared, and that would be sine squared theta plus cosine squared theta is equal to 1. And I would like to rearrange this Pythagorean identity so that I see 1 minus sine squared theta. So in order to get that, I'm going to subtract sine squared theta from both sides of that identity. And we are left with cosine squared theta is equal to 1 minus sine squared theta. So we have an equivalency. Cosine squared theta is exactly the same thing as 1 minus cosine squared theta. So we're going to replace 1 minus sine squared theta with its equivalent, cosine squared theta. And that is the simplest that this problem could get.